most of you don't know me, and I never worked with Sun. I'm Kevin Zimmerman. I did work at UC Berkeley for quite a while, and so I got to see the impact of Sun. And what I propose to do is to tell you a little bit about history, so a little bit of nostalgia, and maybe to talk about where things are now. And I'm really curious as to what you guys think is coming next for this. Oh. No, it's probably. That's right. Well, this is a little embarrassing. I don't actually know how to turn this laptop. I borrowed this laptop, so. Let me just say, so as you know, a lot of this took place a long time ago. It started with a young man who was admitted to ECS in 1975, Bill Choi, as a CS grad student, quickly involved himself in the what became the Berkeley software distribution effort. First release was 77, passed his quals in 1980. Also in 1980, the first DARPA contract arrived for production of Unix that would work on the network, and he decided to take the lead software developer position in the newly formed computer science research group rather than pursue his PhD directly. That culminated in 1982 with the BSD 4.1a release. So he was the first to put the whole thing together. An entire release, the kernel, all the supporting utilities, coordinating it all, getting the release out. He then moved to Sun. So at that point, you know more about the history than I. Sun Microsystems arrived at EECS in 1984-85. I don't know how many of you have seen the first machines. They were steel boxes, a single container. And they used technology called multibus. The boards were about like this. And they had an interesting feature. Sun came out with optical mice, and there was a checkered pad, and you had to calibrate the internal processors. So a service bulletin was released describing how you would wind up the mouse, as they called it, by moving across the board. So the first workstations, Robert Fateman brought them in. Chip, Rob, and Mike, which all you TV aficionados will recognize as my three sons, that ran in the 60s.
Is this really coming up for the second time, Stephen?
So they were server-based, a truce client-server architecture, as you know. Initially, a very hardworking research programmer supported the servers. We had a lot of problems. Professors would say, "Oh, that's really cool." But they'd buy something, a workstation would arrive, and they wouldn't realize, yeah, you need a server. So our sysadmin got really good at hiding disk, which is pretty hard to do in a computer science department where people can log in. It's a pretty open environment. Eventually, in EECS, there were 4 to 5 full-time equivalent employees managing the system administration duties. And about the same in hardware. The first hardware tech came in I think, late '84, and that would rise to around 56, I was an electronics technician trainee. Over the years, we got up to about maybe as many as 150 sons, 150 nodes in the department, about 20 were servers. So EECS bought into it in a pretty big way. They bought the federated naming, our email ran on Suns, storage ran on Suns, the central recharge storage that everybody counted on. Instructional used the Suns. It was the ability to reconfigure them easily was really important for the CS instructional mission. And later on, they also brought in the Sunray technology. So chip design was real big for the EE side, and several faculty were involved in the startup of Cadence Systems, and that wound up using Solaris as the reference architecture. So that worked out pretty well for Sun and Berkeley. So, am I boring you guys yet? These are pretty quiet. I'm not asking any questions. But on the campus side, I didn't see quite as much. We all tend to kind of concentrate on our jobs. I do know, because you needed a sysadmin essentially to set up the server, it was restricted to the better funded research groups. So EECS was bringing in a lot of support, and the other big group was College of Chemistry, and they also had the need for that kind of computing horsepower. So they were pretty big on it. And in an effort to address this cost problem, Central Campus bought 350 Sun 350 desktops, and all in one big buy, put them in a warehouse, and the plan was to sell them at cost to the campus units as they needed them. So that was pretty big. I think they actually sold nearly 300 of them, but it caused some problems. Nobody had negotiated the idea of like restarting the warranty, so that caused a lot of problems. And I heard much later from someone that at Sun, the reliability engineers were looking at how many warranty claims they had, and they thought they were doing really, really well.
So sit well in warehouses.
So Sun Storage made it into the UC data center. It was used there. We also benefited from some highly capable sales reps. Catherine Hartzell and then later Grace Caulfield did a tremendous job of making relationships in the campus and popularizing Sun. There were annual Sun days that a lot of people look forward to. So things were great in the 90s. That was kind of a heyday.
Tell me about it.
Around about 1998, this company from Redmond released version 3.5 of the NT operating system. So that was the first version that actually could hold a candle to be enterprise capable. And at the same time, they launched an initiative to identify the 50 top universities and shower them with money and resources. So that began to give some serious competition. You guys on the inside may not have heard the siren song of Microsoft as loudly, which was, don't deal with that fuzzy academic operating system. We're a really organized corporation. We're going to support this, and you won't be sorry. A lot of people bought it, and it took about a year for the managers to find out their costs, which turned out to be substantially more than Microsoft claimed. And a lot of that, as are quite aware, had to do with the fact that you actually had to touch the console to do any maintenance back then. And that was true for quite a while. But in the meantime, Exchange appeared on campus. Active Directory was put in place. EECS was particularly fortunate. One of the guys who went on to become dean was on the board of Microsoft Research. We had unlimited licensing. They brought in PricewaterhouseCoopers for a security review of the AD. It was amazing. But The other competition was from the NAS vendors, and so NetApp was big. I'm trying to remember, there was another competitor.
Allspec.
Pardon me?
Allspec.
There you go. Thank you very much. So they had begun to get some traction, and people are always complaining about, oh, why are these Suns so expensive? I can buy a PC with a clock rate of 900 megahertz. Look, the Sun isn't, like, it's a third of that. Well, what's the value here? So this was being asked in engineering, where you think they have a better idea of what architecture is about, and the value of a 64-bit operating system, but no. So Linux became increasingly popular. However, the core remained on Solaris. A lot of the groups did appreciate what it could do for them. The constant rebellion got a little more serious after the change of the century, and after the big change that you guys have been talking about, it got impossible, really. Oracle was slow to form policy. I introduced a storage server to replace our NetApp, and we had to do that for about a tenth the cost, running open Solaris, but it turned out to be impossible to get support from Oracle, and when we decided to bring it into production, Oracle would change the rules. I remember installing in the fall of 2010, what was it, Solaris, I think it was Solaris 10, not realizing that all the CIFS code had been taken out. So that was a deal breaker for us, and so we later went to Nexenta. There were other people who did run, mainly Nexenta. Astronomy actually built a couple of big servers and used it for downloading all their satellite data. And they're still doing that, but they had a particularly good system who was ready to fight some of the battles to keep that going. One of the things conspired. That there was less and less interest kind of in Solaris in general. I found it hard to hire undergraduates. In the 90s, I'd have 20 applications for an assistant sysadmin job. By 2004, I really had to about beat the bushes. People weren't interested in maintaining and learning how to run medium-scale systems or those kinds of development projects. All the development interest was revolved around web-based tools and social networking. And, I don't think that's changed much, at least at Berkeley. Funding cutbacks hurt the campus. Right now, it's transitioned to shared services. I don't think Solaris is on the roadmap at all, unfortunately. And I noticed that Oracle doesn't seem to be supporting the EDU market. I've maintained connections with our VARs, but I go up to Sacramento, where they make presentations to the state. Nobody's making any presentations to the universities. So that's the tale of woe. But I guess I really wish I could put this up, but there's a couple of things that I just want to say thank you to all of you in the room and everyone who isn't here. What Sun did was to make certain things really popular that, I mean, Sun altered the computing landscape, as you know, and it started very early on. NFS was put in the public domain. You know, how big an impact did that have? That's immense. The Java ecosystem is another huge development. It's changed the way people do things. I personally think the dtrace technology, that's becoming popular, spreading to other operating systems. That's the information we always wished that we had, in the user community. also important, maybe not as earth-shaking, but pushing the state of the art forward, true client server computing, integrated naming, large-scale automated deployments, zones, CFS, some of the modifications to the networking stack, that were introduced. Those are just some of the ones I know. You guys probably know of a lot more. Thank you from all of us for those things. So you guys yourselves have mentioned some of the legacies, and one is that these technologies are driving cost-effective solutions and bringing stability and performance at scale. And that's why we've always chosen Solaris, as far as I know, from the system community, because it always worked for us. And what happened since the Oracle transition, I would say has been a good thing, because what you see around you, and some of the speakers have talked about this, is a big community, is a much bigger community has been generated. When I was going to put Nixent on our mission-critical storage server at an off-campus research site that I managed, I had to ask, where is the engine behind this? Is it going to be supported, or are we going to be out on a limb in 2 years? And the evidence was overwhelming that Billy Moss, I never knew what Joint did. All I know was I kept running into its name everywhere. Joint had their fingers like in every pie. And
Too many. So
yeah, but it pushed things. There was a lot of interest in there, and that gave me a lot of confidence moving forward. So there are a lot of companies, and as the last speaker observed, the commercial success is kind of the proof of what's going on, and I don't see that stopping. So that's where I begin to ask, what do you guys see as the future? Because you guys are all innovative, and there's an engine at work here, and it's a big one. Where is this going? Some ideas I had would revolve around ubiquitous services. Does any of this technology suggest new ways to do things? I would say, yeah, it does. One thing, and another question is, for instance, can mobile offload to the cloud? And what I mean by that is, one of the groups I worked with developed a project in the mid-90s called InfoPad, and it was a dumb terminal, and everything, pen strokes, voice recognition, everything was uploaded and processed on the back end. And then I look at, well, so what's the Joint Cloud capable of? A lot more than that, say. Could mobile have the connectivity to use that effectively? Is the question. Guys have anything you want to say, or?
Yeah, I mean, first of all, thank you for the history. It's terrific. I think there are a lot of different answers to that question in terms of what does the future hold. I think it's a very good segue. Where is Sinead? Sinead's around there somewhere. I think that, first of all, thank you very much, Kevin.